Hello and welcome to a new episode of the Kubernetes series. Today we're tackling pod replication and the objects that can offer this feature in the Kubernetes Container Orchestrator. If this sounds fun, let's jump straight into it. Up until this point in the tutorial, we've deployed pods as individual objects, and that's perfectly fine for a demo. But if you want to go to production, you can't actually do that, because if your pod dies or accidentally gets deleted, then you have no more pod. There's no automated process to bring your pod back up. And that's why the smart guys behind Kubernetes came up with replication controllers / replica sets. These two concepts, we're not going to go into detail in both of them. You just need to know that they help Kubernetes scale pods to a certain amount of replicas, and they're quite similar. The only difference is how they treat labels. Replication controllers, which are the older object, they need perfect matches between labels and selectors, and replica sets have more advanced matching between replicas and selectors, which is why Kubernetes kind of moved on from replication controllers to replica sets. Yeah, but basically the problem that these resources solve is that they ensure a certain number of replicas, and by replicas I mean instances of the same pod. Okay, and as you can see here, you have two replicas. So the replication controller object or the replica set object asked the Kubernetes API to create two pods for you, two instances. And if one of them goes down, well, the desired state is still two replicas, so a new one will get created in its stead. Okay, which means if something happens to your pods and they accidentally get deleted, you're safe because new ones will be created by your replication controller or replica set. But Kubernetes doesn't advise you to create your own replication controller or replica set. And that's because there are even more advanced replication objects that you can start with. And let's talk about those. Our first candidate in the list of controllers is the deployment, which basically is a construct that sits on top of the replica set. Okay, so a deployment will create a replica set and manage that for you. You don't have to do it yourself, and the replica set will ensure a certain number of replicas. But then you may ask, what's the purpose of the deployment if the replica set can manage the number of replicas? Well, the deployment has other mechanisms it brings into play, and basically it maintains a rollout history, which is very useful in case you want to roll back. So yeah, it allows you to roll back to a previous version of your pod configuration, and also it prevents bad rollouts, which means that if you try to deploy something and things go bad, it will not kill your previous instances until the new ones are actually up and running. Yeah, it makes sure that first your new pods are ready and functional, and only then does it take down your old pods, and one by one. Yeah, it doesn't take everything down all at once. If you have 3 old replicas and you want 3 new replicas, basically it will bring a new replica, it will make sure it's up and running, and then it will take down an old replica, and then it will bring up another new replica, make sure it's up and running, and take down one of the old ones. Yeah, so it will do a sequential rollout. That's what I'm trying to say here. Now that we've been through the theory of a deployment, let's get our hands dirty and go straight to the demo. And all of the materials in this demo you'll be able to find on my GitHub account, which will be linked down below. So if you fancy following along, you'll find the info there. Now, we have a deployment.yaml among other YAMLs, but first we're going to talk about this, and I'll go through it briefly. As usual, we have the 4 important properties in the YAML. API version for the deployment is apps/v1, kind deployment. Under metadata, we have name and labels. Yep, nothing fancy. And then under spec, we have 3 important keys, which are replicas, 3, which means I desire 3 pods out of this deployment. Then there's a selector, which basically says this deployment will manage the pods with this label. And obviously in the template, we need to match that label. Yeah, so as I said here in the comment, these two have to match one another. And then we have a container spec, nothing fancy, an Nginx latest image. Okay, so let's deploy this by running the kubectl apply -f deployment.yaml. and you'll see that deployment.apps nginx deployment created, which is phenomenal. Okay, now I would like to show you the deployment. Yeah, the name is nginx deployment, as I said here. Yeah, same name. 3 out of 3 pods are ready, 3 out of 3 pods are up to date and available. Now, as I mentioned previously, the deployment manages replica sets underneath it. Yeah, so if we do kubectl get rs, which is the short version of replica set, we get nginx deployment minus certain ID. Okay, so this is the ID of the replica set, and also says we have 3 desired and 3 current. So now the desired outcome matches the current outcome. We have equilibrium. Okay, Kubernetes is happy. Now, kubectl get pods final one, and you see we have the name of the deployment, the name of the replica set, and this is actually the name of the pod. So it gets concatenated in here, prefixed with the name of the replica set, which in turn is prefixed with the name of the deployment. Yeah. Now, let's simulate a failure, and we're going to do that by actually taking the nginx image, and I'm going to say here coolest image in the tag name, and I'm not expecting nginx to have this image. What I'm trying here is to create failure. I will try to update my deployment, and it will not be able to because this image shouldn't exist, and it doesn't exist. So how will the deployment handle this? Well, this is fairly simple. If we do an apply again, now you will see if I do a kubectl get pod, but first let's clear the screen. Kubectl get pod, you'll see that this pod here is in error image pool. And what's even more interesting is that all 3 previous pods are still running. Yeah. So the deployment doesn't take down my running instances of the application until the new running instances are ready and running. Yeah. As long as this is erroring, my application, my old application, will still be up and servicing my customers. So I'm not inducing failure into my system. Yeah, the deployment helps me preserve uptime. Yeah, and now let's look at the replica set as well. This is also interesting. So as you can see here, we have 2 replica sets now. The initial one is still happy, 3 desired, 3 current. The new one unfortunately cannot pull the image, so it will remain locked in this status here. I will show you the history. This command, kubectl rollout history, and the name of our deployment. And as you can see here, it has this revision. Yeah. This is the first version, which corresponds to this running replica set, and this is the second revision, which corresponds to this not running or failing replica set. So what I can do now to make things run again is basically I can give it the latest image one more time, but that would just bring me back to this replica set. However, I want to spice things up a bit, and I'm going to ask for a new image, which is a functional nginx image, and I'll apply this one. And now if we look at the pods, you will see that there we go. So initially we had 3 pods which were running from the previous replica set, which is 3 minutes old, and then this new replica set said, yeah, I'm going to create my new containers. The replica set starts with 6, yeah, instead of 5, and it got into a running state. So then one of the old ones, which start with 5, got terminated, and then another new one got created, and then another old one got terminated, and then another new one got created, and then another old one got terminated. Yeah, so it did everything in a sequential manner. So now that we'll do the kubectl get pod one more time, we only have 3 pods from the new replica set. Yeah, the new replica set is this one. It's the youngest in terms of age. And as you can see, 3 out of 3 running. Okay, now let's try to roll back as we are now on our 3rd revision. Yeah, if we do the rollout history, we are now on our 3rd revision, but I actually want to roll back. So I have the command here. It's kubectl rollout undo deployment, and I'm moving back to revision 1. So it said that the deployment now rolled back, and if I do kubectl get pod, we will see that the previous pods, which started with 5, so the pods from the replica set which started with 5 are now getting recreated, and these are getting scaled down. And there we go. And if we look at the replica sets one more time, as you can see here, we are on desired version 3. And if we look at the rollout history, we are now on version 4. But as you can see, version 1 doesn't exist anymore. So this is basically how you can leverage a deployment to guard yourself, first of all, in front of pod failures, and also to be able to maintain a history of your replica sets and to be able to roll back in case you need to do so. Next up on our list of controllers, we have the DaemonSet, and this is a fairly simple one. A DaemonSet guarantees that you will have one running instance of a pod on each node of the cluster. It's as simple as that. You can't scale it up, you can't scale it down. It's not like a deployment where you choose the number of replicas. It's basically, you have 3 nodes in the cluster, you will get 1 pod on every node. If you have 100 nodes in the cluster, you will get 1 pod inside every node. Okay? And this is basically used for services that need to exist on every node, something like a log scraper. Services like that will basically be run as a daemon, okay, in a DaemonSet. That's the whole magic behind the DaemonSet. Now let's jump straight into the demo. Welcome to the YAML file of the DaemonSet. That's also in the GitHub account. And again, we have 4 top-level properties: API version, kind DaemonSet, metadata, again, name, labels, nothing fancy. And then inside of the spec, we don't have replicas anymore, because you don't ask for replicas in a DaemonSet. You get 1 pod per node. But we have selector and template, and these 2 need to match once again, okay? And then a simple container spec, and that's basically it, nothing fancy. So let's deploy the DaemonSet. Apply DaemonSet, and there we go. kubectl get pod. kubectl get pod, and we have only 1 pod, because if I do kubectl get node, I have only 1 node because I'm running locally on Rancher desktop. Okay, so this is the whole magic behind DaemonSets. Yeah, you create a service which will run as 1 pod per node. That's it. We finally reached the last controller in today's saga, and this is the StatefulSet. So this one also controls pods, and you can set up how many pods you want, just like the deployment. But the difference with StatefulSet, or between StatefulSet and deployment, is that the pods inherently are made for stateless applications. This ties into the paradigm of cattle versus pets. Basically, containers are cattle. You don't care about them. You have a lot of them. If one of them dies, you can replace it. I'm sorry, that's how the paradigm is called. I have nothing against cattle. But the point is, if a container dies, it's replaceable, which is why you wouldn't like to have stateful workload inside of a container in Kubernetes. And when I say stateful workload, think about a shopping cart, for example. Yeah, you add items to your cart in your browser, and let's say that instance goes to one of your pods, and if that pod dies, you lose your shopping cart, so you have to go all over again and add your items to the cart. You wouldn't want that. But again, Kubernetes wasn't designed for stateful workloads, which is why StatefulSet appeared, and it basically is able, as a controller, to create an identity for each pod. And whenever you delete a pod, it won't just randomly get spun up with a different name somewhere else. These pods have a certain network identity and a certain identity of their own. And when one of them gets deleted, they get recreated under that same identity. Okay, so they can store state. That's the purpose of a stateful set. And as I said here, the stateful set maintains a pod identity. It has a unique network identifier, so you can go straight to the pod via a certain DNS hostname. And then you can also attach persistent storage to them. And that's basically what you would want of a stateful application. Now, having talked about them so much, let's see them in action. Here we have the StatefulSet YAML, and if you're keen to notice, we don't only deploy the StatefulSet, but also a service, and I'll explain in a few seconds why. But basically, this is a simple service. The only difference is that when we're asking for a cluster IP, we're actually stating none. So the service won't have a front-end IP. It will just have a DNS hostname. And this is called a headless service. And we need this in a stateful set because, as I said, the stateful sets pods will have a network identity and they will leverage this service for that network identity. And let's look at the stateful set. Again, API version apps v1, kind stateful set, metadata name, web. We didn't even give it a label because we don't care about labels here. And then spec selector. This one needs to match the spec template metadata labels. Yeah, as usual, they do match. So the stateful set will know what template to look at. Okay, then we have something new, a service name property. So this service name is basically matching the name of the service we're creating here. And it basically tells the stateful set to use this service to advertise its pod's network identity. Replicas equals 3. This is same as for the deployment. And then we have min ready seconds. This is how much the stateful set will wait for a pod to become ready. Otherwise, it will consider it failed. And then we have template. Yeah, this is a pod template. You've seen that before a few times, so we don't have to go through it. Let's now deploy the stateful set and the service. So kubectl apply -f, and let's give it the StatefulSet.yaml. There we go. We have them created. So if we look at kubectl get pod, you will notice that now the name of the pod is actually the name of the stateful set, and then there's a numeric identifier -0. Yeah, and if we do it again, yeah, there we go. It starts to create them all. Okay, so eventually we will have 3 pods. I will do the wait command. We will have 3 pods in a running state. Each of them will have a numeric identifier from 0 to 2. Okay, now, as I said, these pods maintain their identity, which means if I delete one of them, let's say web -1, now this guy will get recreated again as web -1. Okay, that's what I meant by stateful. Okay, so the container orchestrator recreates the pod with the same identity as before. Okay, and what I mean by that is obviously there's a container under the hood, but if you mount a volume somewhere in the file system of this container where you want to keep this identity, this will basically help you maintain that identity across different pods which get created instead of the other. Now, one more thing, because I spoke about service previously, a headless service and network identity. Let me show you that. I will use this helper pod. So kubectl apply -f helper pod.yaml. And let's enter this pod, but I will do that on a new. I will copy the name. kubectl exec interactively entity bin bash. This should do. Here we are. And now I can do a curl. And the way you can access this pod is by actually going to the pod name dot the service name, which was nginx dot default dot svc dot cluster dot local, I think. And there we go. This worked. Yeah, we got the nginx response. So again, let's try for the other pods. Web1 curl web1. This is the name of the pod. Okay, this is the name of the service. This is the name of the namespace, and then .svc for service, .cluster.local, our local cluster. And one more time we get the nginx page, but this time we got the page from the web1 pod. And finally we can reach web2 pod individually as well. Okay, that's the beauty of a stateful set. Now, guys, thanks a lot for sticking so far. I appreciate any feedback you are willing to leave down below in the comment section, and I will also appreciate a like or a subscribe if you feel like it. Thank you very much, and I wish you a great day ahead. Cheers!